Okay, so yesterday we started looking at the graphs of parabolas and talking about their properties. We talked about vertexes or vertices, lines of symmetry, all that fun stuff. We're going to keep going with that today, and we're going to talk about finding some of those properties without needing to graph them. So let's actually look at the axis of symmetry of these three graphs. So these ones have already been graphed for us, and I see on this one the axis of symmetry is right here. So this one is x equals -3. This one's right here. This one looks like x equals -5. And this one's right here. This looks like x equals -1. So it turns out that there is a pattern. This one's -3, -5, -1. There's a pattern where you can figure out what the axis of symmetry is somehow by looking at the equation itself. So I encourage you to pause the video right now and see if you can figure it out. What is the pattern, how you could figure out that it's -5 just by looking at these numbers? All right, so one thing that I noticed is that this one has the biggest number, right? And it also has the biggest number right here. So maybe just as an experiment, maybe you divided 20 by 2 because there's also this 2 here. Well, if you do that, 20 divided by 2 gives you 10. Okay, that's not 5. But let's do that for the rest of these. What if we do 12 divided by 2? That gives us 6, okay. And if we do this one, 4 divided by 2, that gives us 2. All right, so we have 6, but we need -3. We have 10, but we need -5. And we have 2, but we need -1. Well, actually, it looks like we actually just need to divide it one more time by 2. Or we could have looked at it like we didn't want to divide by 2 in the first place. We wanted to divide by 4. So we actually needed to divide by double this number. So we're going to divide by 4 here, and we actually get 3. All right, now we're almost there. So we have the right number, but we need -3 and we currently have +3. We need -5, we currently have +5. So the other thing that we needed to do was stick a negative out front as well. So there's our pattern. What we need to do is take this number, make it negative, and then divide it by double whatever this number was. So remember, if our equations are y equals ax squared plus bx plus c. None of these had a plus c. We could have stuck one on the end, like +1, +11, plus some random number. We're taking the middle number, right? The 12, which in this case is our b, and we're starting with that number. We said we needed to make it negative, so we're going to stick a negative out front of that number. And then we divide by double this first number. Well, the first number is a, and if I need to double a, I'm going to multiply it by 2. So I'm dividing by 2a. So it turns out that the pattern is if you do -b over 2a, that will always tell you what your axis of symmetry is. So that's basically the key concept of this entire section. If you need the line of symmetry or the axis of symmetry, that's always going to be x equals, and then you do that, -b over 2a. And then that's also going to tell you where the coordinate is. That makes sense, right? Because if you know that the axis of symmetry is right here, the vertex is going to be on that axis of symmetry. So it's going to tell you where the vertex is as well. All right, so make sure you get this written down. And hopefully you're ready to move on. Pause if you need to. So for example 1, go ahead and copy it down. We need to find the line of symmetry or axis of symmetry. Now it's going to be very tempting to head over to Desmos and do it there, but you need to show your work doing it without graphing it. And we're going to use that formula that we just talked about. So we're going to use this one, -b over 2a. All right, so what is my b? Remember, b is the middle number, ax squared plus bx plus c. So it's going to be 36 in this case. So I need -b, -36, over. Now I need 2 times a. What's my a? It's 3. So 2 times 3. All right, 2 times 3 is 6. -36 over 6. And -36 over 6 is -6. Great. Now, this is not a line. This is just a number. I need to make it an equation of a line. So I need to say x equals -6. All right, let's do b now. So same thing. I'm going to find my axis of symmetry. So I'm going to do -b over 2a. So this time, what's my b? Well, I need the middle number. But hint, it's not 24 this time. It's -24. So if I'm doing -24, what do you think is going to happen? Well, it's just going to become positive. So if it's already negative, and then we multiply it by -1 again, now it's going to be positive on the top. And the bottom is just 2 times a, so 2 times 4. Okay, for C, I need my -b over 2a. Well, in this case, my b is my 4, because that's the one that's on the x, over 2 times 5. I'm just going to go ahead and say 2 times 5 is 10. And now this one I need to simplify. How can you simplify 4 over 10? Well, they're both divisible by 2. So that can be -2 over 5. So x equals -2/5. All right, for D, be very careful. What is the b in this equation? So actually, we're missing our middle term. This -10 has to be the c because that's just the constant. So we could rewrite this as 12x squared plus 0x minus 10. The middle term is 0, so our b is actually 0. So this one's going to be, well, don't write -0. That's not a thing. It's just 0 over. Now, it really doesn't matter what we have on the bottom because what's 0 divided by anything? Well, it's just going to be 0. But I'll do it right. I'm going to put my 24 there. All right, so we get 0. So then our equation is x equals 0, which is the y-axis, right? That's the line that goes straight up and down in the middle. All right, and then the last one. So make sure that your a is negative as well here. So it's -2. So we're going to get -16 over -4. Remember that if you have a negative on the top and the bottom, they cancel each other out. So this is really just 16 over 4, which is 4. So this one is x equals 4. Example 2 tells us to find the vertex of this function without graphing it. So remember, if we're finding the vertex, we're finding this point right here. So it's going to be a coordinate point, right? An x comma y. So we need to find the x, and then after that, we're going to need to find the y. All right, so finding the x is pretty easy. What we wrote down earlier is that the x coordinate of the vertex is, hey, it's this thing, the -b over 2a. So we can use that again. In this case, that equals -24 over 2 times 2. Okay, awesome. Now I need to find y. So if I know what my x is, how could I figure out what my y is? Well, remember, this f of x, that means the same thing as y. So what I need to do is I need to find the output. If this is the input, I'm going to input it for all of the x's, and I'm going to calculate what the output is. That's my y. So I'm going to copy this equation down, but I'm going to say y instead of f of x. And all of my x's, I'm going to replace with my x, the -6. All right, make sure you can follow what I just did. So I changed f of x to y. I replaced my x's here with -6. So now I'm going to go ahead and start simplifying. So remember, your order of operations, you need to do -6 squared first. So that's going to be 36. For example 3, go ahead and copy them down and then try them on your own. When you unpause the video, I'll have the answers up here for you. So here are my answers. I have a vertex for each one that I found. Go ahead and check your work with your X and your Y. Be very careful with your negatives in both cases. The only thing that we didn't do here is state if it's a max or a min. So what I need to do now is go back and decide, hey, this vertex, is it at the top of a mountain or is it at the bottom of a valley? So we can tell just by looking at the equation here. So remember, this tells you if it's opening upward or downward. And you look at the first number, and if it's positive or negative, that's how you can tell. If it's positive, that's our regular old U shape. If it's negative, like this one, that one's going to be upside down. It's going to be like a mountain. So this one, we found this point right here. So is that a maximum or a minimum? Well, that's going to be a minimum. This one, we found this vertex. So this one is a maximum.